Hello, this is a video on implicit differentiation. We want to learn about implicit differentiation. You see, sometimes we may come across some equations in x and y in which y is not explicitly defined as a function of x and cannot be easily manipulated to solve for y in terms of x. What we do in such cases is to employ the technique of implicit differentiation. This technique allows us to find the derivative of y with respect to x without solving the given equation for y. And the key to implicit differentiation is d dx of f of y is equal to d dy of f of y multiplied by dy dx. That is, when you are differentiating a function of y with respect to x, you will first of all differentiate that function with respect to y and then multiply it by dy dx. That is f prime of y times dy dx. Okay, we are going to take an example now on implicit differentiation. Example 1, differentiate x squared plus y squared plus sine y equal to 2 with respect to x. Okay, solution. We are going to differentiate each of the terms in that function with respect to x. That will be d dx of x squared plus d dx of y squared plus d dx of sine y equal to d dx of 2. d dx of x squared is 2x and d dx of y squared is d dy of y squared times dy dx, while d dx of sine y will be d dy of sine y multiplied by dy dx, and the derivative of 2 will be equal to 0. So we will now have 2x plus, if we differentiate y squared with respect to y, we will have 2y dy dx plus derivative of sine y is cos y, and we have d dy of sine y dy dx equal to what? Cos y dy dx, and all of them is equal to 0. So if we tidy it up, we will bring those that have dy dx in them together. We will have 2x plus dy dx into 2y plus cos y equal to 0. So if we subtract 2x from both sides, we will be left with dy dx into 2y plus cos y is equal to minus 2x. So we will divide both sides by the coefficient of dy dx to have dy dx is equal to minus 2x over 2y plus cos y. So that's our derivative of y with respect to x. Now we have another example. Example 2 is to find dy dx given that x squared minus 2y cubed is equal to 4x plus 5y. So the solution is to differentiate each of the terms in the function with respect to x. That is, d dx of x squared minus d dx of 2y cubed is equal to d dx of 4x plus d dx of 5y. And if we differentiate x squared with respect to x, we will have 2x. Then the derivative of the next term will be d dy of 2y cubed multiplied by dy dx. Then we have all of them equal to 4 plus d dy of 5y multiplied by dy dx. So in the next line we have 2x minus, now we have differentiated the term in the middle with respect to y, and we have 2x minus 6y squared dy dx equal to 4 plus 5 dy dx. You can see that we have dy dx both on the left hand side and on the right hand side. So we are going to collect the like terms. We have 2x minus 4 is equal to 5 times dy dx plus 6y squared dy dx. So we will factorize dy dx out and we will obtain 2x minus 4 equal to 5 plus 6y squared multiplied by dy dx. And then if we differentiate, we can see that the left hand side can factorize into 2 into x minus 2. So now we can divide both sides by the coefficient of dy dx. That will be dy dx is equal to 2 into x minus 2 all divided by 6y squared plus 5. So that is a result from the differentiation of that function. Now you can try this exercise on your own to practice implicit differentiation. Differentiate x squared plus y squared equal to 4 with respect to x. Okay, this is where we're going to end it for now. Thank you for watching this video. Please don't forget to like and share, and also remember to subscribe to this channel if you haven't done so.